Unit 9, Section 3, Inscribed Angles and Tangents. We have a lot of vocabulary here, so get your pencil ready and let's get started. All right, so an inscribed angle is an angle that's made up of two chords in a circle that have a common vertex. This vertex must be on the circle itself. So we have a diagram here that helps us understand it. A chord is just a short line segment. You can see these two chords. They're in the circle and they have a common vertex. That means that this right here is the inscribed angle, this little angle right here. And so if we look below, it says the inscribed angle is 1/2 the intercepted arc. So your intercepted arc is going to be this right here that you see the pink. This angle will be 1/2 of the measure of that arc. So that's fairly simple. If you see the arc, you get given the measurement. The inscribed angle is 1/2 of that. In a circle that has inscribed angles that intersect, you can see here they intersect the same arc and they are then congruent. These two angles here are congruent. All right? So keep going. What is an arc? Well, the portion of the circumference of a circle. So it's a part of the outside of the circle. A minor arc is named using 2 letters, and a major arc, which is more than half the circle, is named using 3. So we have A, C, and B. The minor arc is AB. The major arc is ACB, because that goes all the way around and goes through those 3 letters. Now we want to talk about a tangent. A tangent is a straight line that touches the circle at one point. This purple is the tangent. It touches it only at that point P. That is called the point of tangency. It's the exact point where the tangent line touches the circle. When a line is tangent to a circle, it forms a right angle. So this right here would be a right angle because it forms a perpendicular line to the radius. All right, so this is now the radius, as you remember, that half of the diameter, and it forms a perpendicular line and a right angle to the radius. All right, and finally, a circumscribed angle is an angle formed when 2 tangent lines form a vertex outside of the circle. So here's our vertex. This is a little more complex. So we've got this as the vertex. These are the 2 tangent lines. The measure of the angle formed by the 2 lines is half the difference of the intercepted arcs. Okay, so it's going to be half the difference, which is subtraction here. You're going to have 240, which is the one arc, and you're going to be subtracting 120, which is the other arc, which gives you 60, and then you divide that. I'm sorry, that gives you 120, and you divide that in 2, and you get 60. So you're going to subtract the 2 arcs and then divide by 2. All right, let's look at some examples. These take a few seconds to do, so just be patient. Example 1 is not bad. Example 1 basically is using what we learned about inscribed angles, that it is half the measure of the arc. So here is the intersecting arc, which is 182. We're going to divide that in half, and that's going to give us 91 degrees. So we now know that that angle is worth 91 degrees. That was fairly simple. Now we have, of course, our favorite, solve for x. So we know that if this is the intersecting arc, then this is equal to half of 100. So 5x minus 10 is equal to 50. I'm going to go ahead and solve this as a normal 2-step equation. So I get 5x equals 60, which means that x equals 12. So I was able to solve x by using the rule I knew as well as the algebra that I know. All right, let's look at example 3. Now we're looking at the tangents that form the vertex. That's called a circumscribed angle. And we learned that this angle is half the difference of the 2 arcs. So what do we know? We know that this entire circle is 360 degrees. We know that this arc is 130. So we know that we would need to subtract 360 from 130 to get the other arc the major arc. That's going to give us 230. So this one's 230, this one's 130. So we would subtract 230 minus 130, which gives us 100, and then we divide that by 2, which means that our angle is going to be 50 degrees. All right, let me repeat what I did. I figured out what this major arc was by taking 360 and subtracting the minor arc here. Once I knew what it was, I could then take that answer and subtract the minor arc from it. Took the major arc, subtracted the minor arc. Got 100, divided by 2, got 50. All right, so example 4 is going in the opposite direction. For example 4, we look at this and we know this is 65. Well, we know by looking at this previous example that that would have already been divided in half. So we want to take this 130 and we want to say that 360 minus 130, which gives us 230. And then we need to take that 230 and divide it by 2 because we want to get to that original arc value. And that's going to give us 115 degrees. So we kind of just went backwards with that one. We basically took 65, times it by 2, subtracted it from the total because that gave us what the other arc was. But then we had to go back and divide by 2 again because the original would not have been multiplied, it would have been divided. It would have been its original number. Okay? All right, so go ahead and give the exit ticket a try. Good luck.